Solve x squared minus 7x plus 10 is less than or equal to 0. All right. Well, x squared minus 7x plus 10 is a parabola that opens up, and it's got a couple of roots that are not too difficult to find. So there are graphical ways to solve this that could do it very efficiently, and you could be done in 15 seconds. But I'm going to do this with a sign table because later on we're going to get into tougher equations where you really need the sign table. So I think we should get used to it as soon as we can. So the method I'm using is going to be a little bit overkill for a question this simple, but it's going to get us comfortable with some techniques that we will need down the line. We start, just like with equations, by trying to factor this. And so we're looking for two numbers which add up to minus 7 and multiply to 10. And I think minus 2 and minus 5 will do the trick there. So this factors as follows. Adds less than or equal to 0. Now, the next thing we do when we've got this factored is we look for what we call critical numbers or critical values, which are either places where this equals 0 or places where it's undefined. This equals 0 according to the zero product theorem, either when x is 2 or when x is 5. And undefined doesn't really come up in this one because we don't have any divisions, so there's no division by 0 problems. And there aren't any square roots in it, so we don't have to worry about that kind of undefined either. So we only have two critical values, and they are 2 and 5. So what do we do with those? We set up a number line. And on that number line, we're going to mark 2 and 5 in order. And we're going to be looking at how this expression behaves, the x squared minus 7x plus 10, or the factored form of it, exactly at 2 and exactly at 5. And we're also going to look at what happens when x is less than 2. We're going to look at how it behaves when we're between 2 and 5. And we're going to see what happens when x is more than 5. The idea of critical numbers is that 2 and 5 are the only places where this inequality can switch on or off, where it can become true or stop being true. And so these are the only 5 places where there can be any differences in whether the inequality is true or not. If we check these 5 intervals, we don't have to worry about any changes anyplace else. Just this is enough to cover all the possibilities. We've got all our bases covered if we look in these spots. So we're going to see how x minus 2 behaves in each of these intervals. We're going to check how x minus 5 behaves. And then the last thing we're going to look at is how does the entire expression behave. X minus 2 times x minus 5 less than or equal to 0. So we'll take care of all the pieces, and then we'll do like a grand total, and that'll give us our solutions. So x minus 2. If x is less than 2, let's say it's negative 3, we get negative 3 minus 2. That comes out negative. So what we're doing here in a sign table, we call it a sign table because we don't care about the numbers that are coming out, only about are we positive, negative, or 0. If x is exactly 2, we get 2 minus 2, which is 0. If x is between 2 and 5, let's say it's 3, we get 3 minus 2 is positive. If x is 5, we get 5 minus 2, positive again. And if x is more than 5, let's say it's 20, 20 minus 2 is positive. You can pick any number you want for each of these intervals, so just take anything that makes life easy for you. Now we do that again with the x minus 5s. If x is less than 2, let's say it's 0, we get a negative value. If x is exactly 2, we get negative again. If x is between 2 and 5, it could be 3 or 4, we get negative again. If x is exactly 5, you'll get 0. And if x is bigger than 5, we get a number bigger than 5, take away 5, that'll come out positive as well. So, overall, what are the signs for this? If we have x minus 2 times x minus 5, that means we have negative times negative, which is positive. Is positive less than 0? Nope. So this interval is not part of our solution. Here at 2, we get 0 times a negative number. 0 times negative is 0. Is that less than or equal to 0? Yep. This is part of our solution space. How about here? Positive times negative. Let's get rid of these signs. We'll do this again. If x minus 2 is positive and x minus 5 is negative, we get a negative number. Is that less than or equal to 0? Yeah. That's part of our solution also. How about if x is exactly 5? We get positive here times 0 here, so we get 0. Is that less than or equal to 0? Mm-hmm. That's part of our solution. And what if we're out here where x is greater than 5? We'll get a positive value times another positive value. This whole thing will come out positive. Are positive numbers less than or equal to 0? Nope. So our solution is everything from 2 up to 5, which you can write like this. Oops, sorry, positive 2, which you can write this way if you like interval notation or inequality notation, or you can use the brackets and say square bracket 2 comma 5 square bracket if you prefer that.